Hi, everybody. Welcome to Ontology 101. This is session 5 of a 6-week cycle where the first two were focused on training how to solicit competency questions from stakeholders. The subsequent two were focused on turning those competency questions into design patterns with like kind of a bit of a logical background. And then today we'll start our two sequence session on converting those competency question design informed design patterns, or this design pattern informed competency questions, but whichever way, into a web ontology language. And before we get there, Bill is going to give us an overview of where the team left off last week, so we're all up to speed, and then we'll shift over, and I'll take the lead, and then we'll talk about OWL. So, Bill, floor is yours, sir.
Great. Yeah, so I'm going to take 5, 6 minutes to summarize what we covered last week. And last week's conversation felt a lot like the conversations I would get into with real subject matter experts, say, for example, in jet aircraft engine maintenance. Th- Kind of the way the questioning went and the points that were made by the people here were the same types of points and the kind of rabbit holes that you kind of want to go down them a little bit, but then you want to be able to extract out of them. But here's a summary of what we covered last week. So we're using basic formal ontology to analyze the decision support questions. We've solicited DSQs, decision support questions, from the experts. We want to start with the low-hanging fruit. We want to get as far down the road as possible on these design patterns without going down too many rabbit holes. There's the rules, right? So what we're talking about is let's identify that material objects, maybe object aggregates like a fleet of aircraft or engines or a batch of parts, sites, right? Space and time, some realizable entities. Think that's kind of like well, what do you mean by that? Well, that's like roles, disposition, functions, maybe some relational qualities. But yeah, we want to include that in our thinking. Processes or activities, and then time. So we've got space and time, material objects, processes in there, right? So we picked a decision support question. We had like 8 DSQs, decision support questions. We picked one that was pretty straightforward. Where do the aircraft in my fleet operate? So as a maintainer or a manager or a director of maintenance, I have a fleet of aircraft. I want to know where they are in space and time. So what we did is we used that low-hanging fruit uh, process there, where we have our material objects or object aggregates, realizable entities, processes, sites and spatial regions, temporal entities, and then GDCs, generically dependent continuance, what we'll call information entities. And then we started to fill this in, and we intentionally went down a couple rabbit holes just because that's going to happen in every conversation. And you want to let the subject matter expert know that you can eventually go down those rabbit holes because you're going to need to, right? So things where we started to say for this DSQ, okay, we care about airports, the physical aspect of the airports, not just the site, right? And the aircraft and the fleet and the jet engines. That's not really part of this DSQ, so we put a line through it because it's kind of a rabbit hole. Because now we're talking about decomposing the engine in the runway, right? So those are rabbit holes, right? And if you kind of just survey across this list, I crossed out what we kind of started to say, okay, let's not go down that rabbit hole. It's important, but for other DSQs. Then after we had the conversation last week, I filled in this information entities, the generically dependent continuance, with some of the things we had discussed in the conversation, right? And then we talked about, if we're going to talk about flights and operating aircraft operating, we went through this discussion about potential axioms, self-evident truths. So if you have a flight, that means there are certain axioms of that. That means there's a participant in that flight. That participant, that material object that is flying, has certain capabilities, right? And that's, let's call it a flight capability, just to go here. And that you can decompose that into a propulsion capability, a lift capability, and an attitude or steering capability. And that realizes that flight, right? And then the flight, another axiom is the flight happens in time, right? And it has certain parts to it. It accelerates, it takes off, it ascends, it cruises, and then it descends and lands. Now, bear with me because this is some problems came out here, right? This happens in a certain sequence. You could say that the acceleration precedes the takeoff precedes the ascent, et cetera, et cetera, et cetera, right? So you don't land before you ascend, right? So these are kind of axiomatic truths. The flight happens in time and in space, and that site occupies a certain region. Now, people started to bring up points to our axioms, like, and here I kind of captured them in a box up here. What about things that are launched? In other words, cannonballs don't have a propulsion capability. You launch them, right? They don't have a lift capability. You launch them, and they certainly can't steer themselves, right? They kind of just go in a particular direction. What about clay pigeons that don't land, right? You shoot it up in the air, someone blasts it, it breaks into pieces, and a clay pigeon lacks all these capabilities too, right? So so then you ask yourself, okay, what about our axioms? So maybe in our conversation, we're talking about a particular type of flight. It's becoming more like it's not just any old flight. It's let's give it a name, controlled flight. Maybe that's a bad name, but we're talking about something different than just flying through the air,
I'm
right?
curious. So
Controlled flight is what an aircraft does. All
I'm
right,
curious. I wouldn't
that's
even
my
say,
John. Go ahead. Go ahead.
yeah, I wouldn't even, I wouldn't say that a cannonball flies or a clay pigeon flies. In fact, you
Great
didn't
point.
either. You said things that launch, not fly. So,
Right. Things that
yeah,
are launched, they don't, right.
yeah.
Exactly. But
So I'm glad to see
the
the other
point being
perspective.
here is these proposed, if you want to call them axioms,
Mhm.
people started to immediately see problems with it, right? And this is, and people on the call, this is where you're letting the subject matter expert know, like, okay, these people ask serious questions about, like, we're not just slapping together this design pattern. We're asking some really good questions. Are they rabbit holes? Maybe some of them are,
Mhm.
but it's getting us to where we need to be in our design pattern. So John, that's kind of where we oh, last point. Let me make this last point about let me bring up, and I'm going to put these things in the chat so you guys you can have them. Here's that decision support question. Where do the aircraft in my fleet operate? My technique working with the people at Kubrick is this DSQ sets up column C for more specific questions. What do you mean by an aircraft? What are the types of aircraft that make up my fleet, et cetera? Right. So there's all these. What are the phases of a flight?
Mhm.
Right. So again, some of these are kind of rabbit hole. They're kind of going down a rabbit hole. And then column D is from these more specific competency questions, our potential classes in our ontology.
Mhm.
And then back there is column E is where we put in, okay, if we have an aircraft, what's the data associated with that? Probably a tail number or a serial number.
Mhm.
And those are in that slide right here,
Very good.
right? Airport code.
Excellent.
So I will put these in the chat right now
Mhm.
so you can all look at them. And again, we have not finished this process, but we don't have time. We're going to go on, and I'm going to
All
hand it
right.
back over to John at this point.
Fantastic. Well, this is great. I'm glad to see where you guys landed. I think this is plenty of fodder to start building in OWL. And so I'm glad you pulled this slide up. So this is good. I'd like, if you don't mind, I'd like to talk about this slide because I think it'll be good for us to work through as we're thinking about how exactly we represent the design pattern in the web ontology language. So for that, because this is 101, I'll give you a very brief overview of what OWL is and why we use it, and then I'll start talking about, I'll like lean directly into the design pattern itself and start showing you how to model. But OWL is a standard language that is common among ontologists. It's it's capturing a fragment, or it's supposed to capture a fragment of description logic, or at least be isomorphic to a fragment of description logic that is decidable. And so it allows us to represent things of binary relations within a finite domain. And this is important because anything beyond that becomes undecidable, which is to say that you can't ask a computing system running such a language whether some question or proposition is false and be certain that you will get an answer. You can do that in OWL. You can ask a computing system using this language, extending this language into your domain, whether some proposition is false or true, and you can be sure that within a finite amount of time you will receive an answer. And you won't have to get into that weird headspace of, is my computer just looping, or can it just not answer this question, which is what you do in a decidable space. And so this is some of the motivation for even having a description logic or an OWL type language that lets us represent ontologies, because as you know, we try to implement design patterns and representations in computing systems. So OWL itself, standard, again, very common. It's also a very weak language, so it allows us to represent some of the logic that is implicit in other standards that it's built upon, like RDF, which is just that kind of triple structure that you see in any kind of turtle file or ontology, most ontology representations, subject, predicate, object. And then built on that is we have things like subclass relationships, which we see all the time when you're thinking about how types are related to other types. And then on top of that, you get some logic. So like two classes being disjoint from one another, or one class always having some relationship to something in another class. Like that's the logic, and that's what you'll get when you're representing things in OWL. Yeah, it's, I think, a little easier to see than to say. So let me share my screen here. So I wanted,
I'm going to put that stuff in the chat right now that I
perfect,
just
perfect,
showed you.
perfect. And I'm gonna illustrate some of what I'm saying, some of the features of OWL through the lens of basic formal ontology, partly because I'm a fan, also because it's very well axiomatized using OWL. So it's kind of easy to highlight some of the features of OWL that will guide us as we're building design patterns. So this is the BFO hierarchy. We have things divided into continuant and occurrent. Continuants are just things that exist over time or through time, and occurrence are things that happen, like processes and whatnot. Roughly speaking, that's enough for us here. But what I want to highlight, and I'm pulling this up in the Protégé desktop editor. You see continuant. I've highlighted it here, down here in this description side under the annotations. It's kind of like textual descriptions of this class. You'll see logic. You'll see equivalence or potential equivalence assertions. You'll see subclass of, you see axioms. These are all logic-y kind of references. Importantly here, you'll see disjoint with, right? This is what I'm being presented in Protégé in this editor is kind of like a built-in interface that reflects OWL semantics. So these things were developed together and like implemented, or at least OWL was implemented into the Protégé viewer. And so if you were to dig into like the OWL spec itself, like the standard itself on the W3C website, you'll see things like a characterization of disjointness, and that characterization of disjointness at a semantic level is going to reflect what you see right here in Protégé. And what this means is there is no instance, no thing in your model that you build with your ontology that is both a continuant and an occurrent. That's what it means to be disjoint. Those two classes do not have any intersection. And just to make that crystal clear, I will show you a bad example where I am both typing the same thing as a continuant and an occurrent. And so I know I moved a little quick. What I've done is I've gone from the class view in Protégé, which shows you the class and subclass relationships in a hierarchy. I've dropped over to this tab, the individuals. These are the instances that will be instances of things in the class hierarchy. So like, John Beverly is a continuant. There's an instance. I'm right here. I'm not repeatable. It's just me. I am a continuant. I exist over time. I might fall into that space. You would place something referring to me, John, over here in the individuals tab. of a type continuant. And what I've done here, just to highlight the kind of conflict of disjointness, is I've made something that is both a continuant and an occurrent. Now, here's a way to see why that is a problem. I'm going to click up at the top. I'm going to click into, maybe you can't see this part of my screen, but what I'm going to do is I'm going to run a reasoner, and I'm going to pick Hermit. This is my favorite one. And you should see, can you see the inconsistent display? You should see help for inconsistent ontologies as something that pops up. Did you see that? Or do I need to share my whole screen for you to see that?
No, I see it.
You did? Okay, good. Okay, so this is basically saying my ontology is inconsistent, and it's exactly for the reasons I've said. I've asserted something that's straightforwardly inconsistent, and I clicked an explanation. Protégé has this very good feature where you can just explain, and it's saying continuant is disjoint with occurrent. Bad example is asserted to be of both those types. You have to give up one of those. You can't have them both. I will just drop occurrent. I will synchronize my reasoner. Everything's fine. No inconsistency here. I click back on continuant, and I'll make this a little bigger here, but you should be able to see in this class view, I've got an instance bad example right there. So you're gonna spend a lot of time when you're dealing with logic, like OWL, implementing design patterns, thinking about this space. This space is where the reasoning is done using the in-house reasoners like Hermit, Pellet, and Elk. Up here where you see the annotations, these are a lot of just textual definitions. These don't go into reasoning, they're ignored by reasoners. And frequently when we're trying to both test consistency, conformance, and whatnot for our graphs and our design patterns, we'll either be running reasoners or using something like Sparkle to do something like targeted reasoning on the structure of our graph. Both Sparkle and the reasoners play in this space for the most part. So let me drop that example. Don't want to keep it. I'll stop my reasoner. Okay, so this is just, again, just highlighting disjointness. There are going to be places where we're looking at our design patterns, and it's likely that we'll want to assert that some things are disjoint from others. Maybe like, and like you'll have some continuity things and recurrent things. Now, I will say if you're importing like a upper level structure like BFO that is, kind of built on relationships like disjoint from, as we see, then anything you create that's a subclass of this hierarchy is going to inherit the parent axiom. So if I click down here, continuant fiat boundary, like a line, or easier, a surface. So these are just like immaterial entities that that kind of like the spaces. I like to think of a line as where two flat surfaces intersect and a point where two lines intersect. And so if you're thinking of it that way, a surface is just like the surface of John's body, like the thing covering me, it's a site. Now, it is as you see, a continuant ultimately. It's also a fiat boundary. It's an immaterial thing. It has no matter as parts, and it's an independent thing, which is to say it can exist without necessarily being dependent on anything else. All of these items in the hierarchy above it have axioms, all these classes, and they are inherited downstream. So like every continuant is continuant part of only some other continuant. You will see down here that is also true. We are inheriting this from our ancestor classes. And so it works just like that. If you assert something at the high level in the class, any of the subclassing you create about that is going to create like that kind of inheritance. And so you'll get those axioms for free. That will be important because as we're looking at the design pattern, we're going to be asserting new classes when we're building the structure. And those new classes built on something like BFO are going to have inherited subclass or inherited axiom constraints. And we'll want to check our reasoner intermittently to make sure that we don't end up saying something inconsistent or that we don't agree with as we're building. I'm going to pause there. Does that make sense what I'm saying? So just kind of high level. Very good. Very good. So I saw in that design pattern that we were largely talking about look to me to be a process. Is that right? You guys tell me. So what we're going to do now is I'm going to shift over, kind of gestured at some of the logic. It will be, I think, even more intuitive if I start actually building and then highlighting aspects of the logic as we go. But how about you guide me in the building that out that design pattern? You tell me what I should be placing where, and I will start doing the placing so that you can see it done in your face. But you guide me. What should I model?
So the
Well,
basic, I was gonna say, start with probably you'd have to find a class or an instance of flight because we're doing a material entity of a airplane for some sort.
Mm-hmm.
So I think building an instance of a aircraft, or maybe even if the axioms, yeah, maybe just a class aircraft.
Okay. We got an instance aircraft right there. That's probably the one we're gonna actually be talking about. If we have a specific instance, we should probably put it under a type. I think it's plausible to have an aircraft class because there are plenty of aircrafts. There's not just one, right? So let's see. I'm going to go out on a limb and assume that aircrafts have material parts. They're the sorts of things you can touch. So I'm gonna go ahead and put that under here, aircraft. And observe. So now what we know is that aircrafts have material parts. They are continuous. They exist over time. They probably participate in many different processes. They have continuous parts that are only continuous parts, and they only have, or I'm sorry, they are only themselves part of things that are material entities. All right, what next?
Why is aircraft not under one of those subclasses? Like object would seem to fit it well, right?
Great question. I was hoping you'd ask. So aircraft right now is listed under some just material entity. So it's just the sort of thing that has material parts. There are three subclasses of material entities. An object aggregate, which is essentially just a collection of disjoint objects. And so like, me and John Lennon, me and Jeremy, like we might form an aggregate. Aircrafts are probably not characterized in that sense. So we're not just like summing things together to get an aircraft. They seem like legitimate objects on their own. Fiat object parts are are essentially parts of objects that seem like they are plausibly worthy of names. And so examples being things like the upper and lower lobes of the left lung, the Western hemisphere of the Earth. We wouldn't properly say these are objects so much, even though they have material parts. They are worthy of naming. People fight wars over these sorts of things. But they're in contrast to objects proper, which is, I suspect, where you were headed, or well, you said that's where you were headed. So objects here are a specific kind of material entity, particularly the kind that have some sort of causal unity over their structure. A way of thinking about this, sort of a rule of thumb, is if something is an object and it has causal unity, if you were like to move some proper part of it, the rest is moved as well as a matter of necessity. So John Beverly is an object, partly because I have causal unity, this sort of boundary around me, and if you move my parts, then I have to move with it, or you break me, right? And that is sort of like a rule of thumb. I think it would apply here. So when we're thinking about aircrafts, what we want to consider is it's the case that in every instance that we might encounter of an aircraft, it has causal unity, like maybe some material boundary or kind of engineering fastening, such that if you were to move one proper part of it, the rest moves as well, else you break it. I'll ask you that. So what do you think? Are aircrafts in every case those sorts of things?
I think aircrafts are objects, not object aggregates. However, I'm a little confused on fiat object part.
Mhm.
If the Western hemisphere is, I think, is the example you used, is a fiat object part, does that necessarily make it like the globe or the Earth object aggregate? Or can regular objects have fiat object parts, or can none of them have fiat object parts, and it's a totally separate class? I mean, it is a separate class. So
Yeah, so you see here in the definition, so fiat object part is a material entity. If it exists, then it's a continuant part of some object. So you're going to have some object that is a part of, and it's demarcated from the remainder by one or more surfaces, so like a fiat surface. So a way of like the example of the the Western hemisphere over the Earth is kind of a paradigmatic example. So the Earth itself we consider an object, and if you slice it, there's some kind of boundary, that surface cutting eastern and western hemispheres. That's the kind of demarcation of it. One side being important, the other side being important too. Important enough to warrant naming as like an important.
okay, so it's pretty subjective then, I guess, from what I can tell.
There's a matter of subjectivity, with the exception that, the Western and Eastern hemispheres exist regardless of us. Like it's out there, right? Like there's the surface there that demarcates both. The subjectivity comes in insofar as how we find it. So it's not really a subjectivity that differs from how we find other sorts of surfaces or other sorts of objects. But I hear what you're saying. Bill, yeah.
Yeah, so just last night, my wife and I were flying back from Nashville, and she said, I like to sit in the front of the cabin inside the aircraft. I said, well, I like to sit in the back. So the front and the back of the interior of the cabin or the inside of the aircraft, I think those would be fiat parts of the aircraft. The front versus the back.
But yeah, I think so. Now back though to the question, so we don't go off too long. Aircraft, is it an object or a material entity? I think it's plausible that in every case, aircrafts are not like just parts of objects, not aggregates. But question here, is it merely a material entity, or is it something that has this causal unity around it? So what do you think?
I do think so.
Mhm.
It's designed for a purpose, so every part has a function. It's highly causally dependent, or
Yeah, I agree. If you take an engine or a wing off an aircraft, it's not really an aircraft anymore.
Yeah. And if you move the aircraft wing, you better move the rest of it, right? Or we're going to be in a real crappy situation. So I would be inclined to place aircraft under object as well. Very good. So okay, how about we're next? So we've got object, we got the aircraft as an object, we've got an aircraft instance. I'm going to go ahead and drop that under object, the class. So now we have the connection between the two. What else should we be modeling?
there's fleet of aircraft, and we stay a bit in the same neighborhood now,
Fleet of
which
aircraft.
would be typically an object aggregate.
I would think so. So now we have a bunch of objects that we can like sum together, and then they go into a fleet, right? Like that seems a plausible place to categorize them. So I'm going to go ahead and put fleet of aircraft right there. All right, and I'm going to make an instance.
Hey, John, while you're doing that, if you look in that spreadsheet I put in there, if you look at the third tab, fleet of aircraft, that's an actual fleet of the bomber aircraft that make up the Air Force.
Okay.
That's open source.
I got you. You see what's happening here is there's like an additional, the Protégé editor does some disambiguating when you're treating like when you do multiple name or the same name essentially for multiple things. And so there's a somewhat standard practice of adding a number on instances, partly to avoid this, but partly to highlight that you can have multiples of instances and not multiples of classes. And so I'll just go ahead and follow that practice here. And as you see, there's no conflict. So the editor didn't attempt to disambiguate with what was essentially this prefix you see up here, or this suffix you see up here. All right. What now?
Airport and airport site are nice, because I think airport is sort of a challenging subject. I think the site is more straightforward, because the site is a site. That's sort of the surface where the airport is located. So I think airport site is just a site in mostly. But the airport is like, yeah, what does it? It includes roads, buildings, the runway.
Right.
I
Yeah.
mean, that's that's that's
Certainly they have material parts. So this is airport.
yeah.
Now, what should I say? Airport. I try to do disambiguating with labels as much as I can. So there's like airport in a building sense, but you're correct. It's not just building. They have like tarmac, and so aircraft of all sorts, not just buildings. They have parking lots and things of that nature as well. Many people would probably want to characterize those as part of the airport. Uh, how should we characterize this? What should we say?
Probably material entity because it's not an object. It's not really designed. I mean, a building can be designed, but the airport itself evolved.
Hmm.
I don't think it's an aggregate because well, you
I
could say maybe an aggregate of sort of infrastructure objects if you would, yeah, like to say it. I mean, there is something to be said for it,
Hmm.
but um,
I think this is one of those tricky ones, and I've written here airport material entity because we what we want to do is describe, right? Like, and what we're describing is kind of a highly ambiguous word or underspecified word, and I don't want to say anything too strong and say like airport and then define it as like a building because somebody's going to come and have a legitimate use of the word airport that includes things that are not building. And now I'm in a situation where I've built a formal representation of something that conflicts with a legitimate use. And now I have to get into this battle with either I'm right or they're right, or blah, 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 blah. I'm not sure. I want to avoid all of that and just kind of describe as best I can, what seems to be common across the various uses. They do seem to involve material entities. How they involve it, that's TBD. We'll probably have to spell that out in some detail. But I would be inclined to not just spell that out, but even highlight that in the label itself so that other ontologists don't get confused. And so it's not going to be the sort of label that you'd see in a user interface for sure. But it'd be something that would help me as I'm designing or like building the ontology itself. Airport material entity. Now I have a bead on the breadth. So, and if I saw that, I'd immediately be thinking, well, that makes sense. There seem to be a lot of different uses of airport. I don't want to say anything so strong that it's false, but I also want to describe as much as I can that's true. Now,
Well, couldn't you put the aircraft or the airport underneath of a object aggregate because it's a summation of a whole bunch of objects, runways, buildings, etc. as under an object aggregate, and then say it's located in this three-dimensional spatial region.
hmm.
Because the way you have aircraft and fleet of aircraft separated, I was curious about that, but you could define the airport aggregate as buildings, runways, maintenance facilities, parking lots, whatever you want to do.
Are airways and runways tar like objects?
Yeah, I was
Yeah,
about to
they're
say that sounds more like a grouping of like different spaces as opposed to parts of something. Maybe like a bunch of airports, I would imagine would be an object aggregate, but in one airport itself, I don't think so.
Yeah, so that's it goes right in line with what I was saying a minute ago about like trying not to say anything too strong because there may very well be characterizations of airport that are plausible justified uses where they do just mean like genuine distinct objects. And like an aggregate of those would be an object aggregate. But if I go forth and assert that outright now, then I have to be committed to saying things like, well, look, if you're an airport and you have a continual part that's like tarmac, now you've got an object, sites, now you got an object, and and that might lead to some trouble downstream. Now we can nevertheless relate those to airport material entity. So we can create classes for things like tarmac. We can create classes for the buildings. We can do all that specification and spell it out and then connect them with like parthood relations or location of relations, like embed them in space and whatnot. That's always fine. But as for like where that anchor is, we probably want to stay kind of broad and allow for a little bit of ambiguity because that's just how the words are used or how these things are picked out more specifically. Yeah, Bill.
We started using words like campus or
Mhm.
district, like airport campus or airport. We would try to find terms that captured that, hey, it's a collection of material entities.
Mhm.
Um, but this was one of the biggest problems we had in the intelligence community were this collection of buildings that created a facility.
Yeah.
You, yeah, it's a problem.
Yeah,
It's a
honestly, part
challenge.
of part of the motivation for me beating this drum was born out of the like I
Yeah,
was an observer who walked into a bunch of disputes over facilities, targets, and countries, and I was like,
yeah.
what the hell are you guys arguing about words for? And so now I'm like, let's not do that. So uh if I'm not mistaken, there were some processes involved. Am I remembering that correctly?
John, wait, before you go to the processes, a quick to extract out of this rabbit hole, one thing that is clearly a site, an immaterial thing, is the airspace above the airport.
That's right. Yeah.
Sometimes I like to add that stuff in quick so we do the low-hanging fruit and we get some things on the into the ontology.
Yeah, absolutely. That makes sense. Yeah, there certainly is forgive me, I forgot to put that in. I intended to, but definitely there's a separation between like the airport, the material stuff, and then like the site. I mean, this site is incredibly important for airports. They have all sorts of boundaries and like cutoffs, and they're demarcated or at least defined in terms, these spaces in terms of the material entities themselves. So the airport site has a relationship to the airport. It's basically, roughly speaking, the area of
And
it.
the airspace that sits above the airport site, the airspace is defined and
Yep.
it can expand and contract, but that's a real thing. Is that not it? Well, it's not a real thing. It's an immaterial thing.
It's a real thing. It's
It's a
just
real
not a
thing.
material real thing. It's a real
Yeah.
thing. Yeah. And to be clear, like it's not, because this sometimes is a point of confusion, just and some more of a BFO thing than an owl or modeling thing, but like it's not the air molecules, right? The site above an airport is not like the molecules of air. It's the air moves through it, right? So the material stuff goes through it, but it's nevertheless separate. So, all
Yeah.
right, but yeah, back to the so I recall, and forgive me for having such a feeble memory, but I recall mention of some kind of processes, some kind of like flying or flight perhaps processes. Is that right?
Yeah, there's flight and flight phase.
Flight and
Yeah,
flight.
or even before that, like engine startup.
Mhm. Let me do some
Yeah,
of the
which
stuff. So or the occurrency stuff. Because I want to highlight like how these things can connect up. And by that, like, the two sorts of the hierarchy, the continuant and occurrent. And so, um, they're flights, right? So what exactly is a flight? Is it like, tell me more about flight. How are you guys thinking of flights?
Some like propulsion process that allows for something to exist within the air and then land at some point.
Okay, so it was a process. That's what you were thinking. I may have like been leading you. But it sounds like you were led already. So processy thing is existing over time. Yeah. Okay. I'm down with that. Flight. Say flight process. Okay. Again, my feeble memory. I want to say that there were parts of processes that you were talking, parts of this particular type of process.
yeah, flight phase.
Hmm. Like a flight phase, like flight phases. And something like ascent and descent. Was that right? Ascending.
Yeah, taxi, takeoff, ascent, descent, landing, cruising.
Okay. Okay. And there was some precedence, right? Like one happened,
Yeah,
the other. Okay.
Yeah,
Mhm.
and the importance of those,
Mhm.
one of the things we discussed is once you say flight flight process has part flight phase,
Mhm.
now you can start to design a how many minutes should it take to
Mhm.
taxi, to take off, et cetera, et cetera. Now you can start making prescriptive statements.
Mhm. Very good. So I'm going to now jump over and start doing some of those connections. I'm going to jump over to the object property plugin or tab here, and you'll see here listed, these are a bunch of relationships in BFO. They're gonna, the labels are gonna look confusing for the most part, but basically they're connecting one part of the class hierarchy to another part in various ways. So the ones I'm I'm going to be looking at specifically here are going to be part of relations. You'll note that in BFO we have like a continuate hierarchy and a current hierarchy. The things in space or in time, the things that exist over time. And they have two separate part-hood relations. So there's a continuate part-hood specifically for continuous and a current part-hood specifically for occurrence. And so you will see that here, like has or current part, or current part of. These are just restricted to occurrence-like processes. And so if I want to say that ascent, the class, like instances of the class ascent process are parts of like a flight process, I'll use the occurrent object property to do so because processes are occurrence. If I were to try to assert continuant relationships there, I get an inconsistency because continuance and occurrence are disjoint. And these part-hood relations are defined with respect to each of those hierarchies. So I can say a couple of things. I'm going to ask you some questions now. So I want you to tell me, should I assert at the class level, like right here, that a descent phase is a part of a flight process? And let me say what that means at the class level. And I'm operating here at a class level to object properties. That means that everything that is a descent, any instance of descent phase is an occurrent part of some instance of a flight process. Now I could also make an assertion at the individual level. So over here, if I were to say create descent phase 1 and also assert flight process 1, I could assert that descent phase 1 is a current part of flight process 1 directly. Now the difference here is one of those assertions, specifically the individual to individual assertion, is a lot weaker than the other. So if I just say descent phase is an occurrent part of flight process, that just holds for those triples, right? I could hold that occurrent part. Now, if I were to say it at the class level and say any instance that falls under descent phase is an occurrent part of some flight process, then I will entail something like the assertion of this triple, but not the other way around. There's the notion of strength. So let me pause. Do you understand the distinction, that kind of asserting at the class level versus the individuals? So individual to individual, or all of the individuals to some individual. There's one. Do you understand that kind of difference first?
Yeah, I
Okay.
think you're saying, John, that if you do it on a class level, then the ascending phase. No, let me scrap that. Would you then, you wouldn't say that every flight process has a descent phase then, no?
Yeah, you might
That's
not want
something
to say
else.
that. Yeah. So that would be a different. So you can do this, like you can assert these relationships back and forth, like in either direction. I
Yeah,
gave you, I think, because I was trying to highlight first this difference between
yeah,
individuals and classes. I gave you, a plausible case of every
yeah.
descent phase, part of some flight phase. You're absolutely right to point out if I were to go the other way, say every flight process has a current part, some descent phase. That might not be true. Like maybe
True.
there's a plane
Yeah.
that flies up into space and just continues and never comes back and just never descends, right?
Or
Uh,
stops after taxiing for some
that's right.
reason.
That's right. Exactly.
Yeah.
Exactly. So,
Well, that's something I brought up when we were talking about flight last time, when we were talking about the processes within flight. Like, do you actually need a descent phase or landing to fly? That's not really part of flying. That's only required to take off again.
mhm. But there does seem to be, yeah, exactly. There just seem to be like a way of characterizing some of the logic here, even if we don't think of it. And it's the other direction, right? So if you have a descent phase, it's plausibly part of some flight process, right? Insofar as we're thinking of like a flight descent phase,
Yeah.
right? Yeah, Bill?
And this kind of goes with Alex's point too, and the whole discussion is there a difference between controlled descent and falling? Remember, we threw the rock and it fell back to Earth versus the descent seems like it's a controlled thing, perhaps. So I would argue that every instance of a descent means that that was part of a flight. So I would say it at the class level. There's my argument.
Mhm.
Would you need to introduce some sort of like property that would measure just how controlled it is? Because like I can imagine different levels of control,
Mhm.
like totally
Like,
uncontrolled free fall versus like,
mhm.
oh, there's a lot of turbulence, but we managed to get it on the runway, you know.
Mhm. Probably not at this stage, but for sure, if we were going like closer down to the domain and we wanted to make that kind of distinction, yeah, absolutely, we'd probably introduce some aspects of measurement here. What I am hearing at this point is that I should probably add a restriction, like a subclass restriction, some logic axioms that connect descent phase to flight process. I will do that by clicking this little subclass button. Now, ultimately in OWL, everything, everything, all the logic is subclass type, subclass to subclass, instance to class. That's how all the logic is characterized. So anytime you're adding an assertion, an axiom at a class level, this is interpreted as like a subclass of relationship. And what you can think of what I'm about to do is saying anytime you have like any instance of descent phase, it's going to be related to some instance of a flight, I'm sorry, yeah, some instance of a flight process. And this relationship of like a current part of is ultimately holding between instances, but in the logic, like the underlying OWL has to, there's going to be the introduction of like classes between, because the semantics are actually spelled out in terms of classes. We call these sometimes anonymous classes. They're like smuggled in to the back end. You don't really see them in the editors. Sometimes you don't even see them in the serialization, so you won't see them in Turtle. You'll see them in some of the more expansive serializations of RDF. We won't go into too much of that here, but in subsequent, working groups, I'll speak ad nauseum about the importance and dangers of anonymous classes. But for here, to kind of get you off the ground, as it were, pun intended, what I'm going to do is go to this class expression editor, and I'm essentially saying I'm going to relate this class descent phase to flight process using that occurrent part of relationship. And so in the editor here, because the lexical interpretation as to group things, you probably, if you have like a word with spaces, like an object property with spaces, you need to spell it out and put these little quote marks around it. Note that I put in some here. This is a logical connective that's part of OWL, and I always have to like connect the object property through some logic to the thing it's supposed to be connected to, the class in this case. And so I'll do that by saying flight process. Now,
It's not showing, but we know what you're doing.
oh, is it not showing? Okay, here, gosh, I wanted everybody to see. Maybe I'll just share my whole screen and share it all. Ain't no shame. Okay, let me try that again. So I did type it in here, but look, observe I had clicked on the class expression editor under this subclass of button here, and I just typed in a current part of, and then connected it with some flight process. And so this is how I build this relationship that I've been describing. Every instance of descent phase is connected to some flight process instance. And now I've got a connection there. I've got some logic here.
So going back to that discussion, John, so the descent phase, so hypothetically our aircraft takes off and goes into space and never descends.
Uh,
Um, would that descent phase, like in the ontology, is there logic built in that says every flight process has to descend? Like that,
so not here.
not here.
So
Okay.
yeah, if I were to assert, say, at the flight process, right, that a flight process always has an occurrent part, some descent phase, then I would
Mm,
be on the hook for that. And then you might have counterexamples, right, of the sort that you're describing.
got it.
This, on the other hand, is just saying like if you're already in a descent phase, you're part of something bigger, right? And I could do some,
John, could you? This goes to Sam's question. I was thinking about this. Planets don't fly through space; they orbit.
right.
Right? They're not really flying because they're never going to descend
Mhm.
unless they smack into something else. So I would say flight it requires some sort of descent. Otherwise, it's orbiting. It's not flying.
So like would you characterize like a space rocket that's ascending into
It's
this,
never good.
that it's just going to go on,
Oh yeah,
it
yeah,
it gets caught up in orbits.
it does. But
There's
it did
part of
fly out of
it.
the yeah,
Seems like it might
yeah.
be flying. Now you can imagine a scenario in which, for whatever reason, it just keeps going. Like it misses its orbit, it doesn't get caught in the right trajectory, like gravitational path, and it's just like, okay, bye. Yeah, I think I might want to call that a flight. So what I've done here, though, is Bill was talking, as I went ahead and asserted a similar relationship, that same relationship actually, to ascending. So now what I have is two links to flight process. So if you're ascending, you're part of a flight process. If you're descending, you're part of a flight process. And I did that because I wanted to now assert um, temporal relations between them. One comes before the other, right? That seems plausible. It seems like descending comes after ascending, right? Let me see how I can express that. There is a temporal ordering in BFO. There's this precedes or preceded by. I'll show you what that looks like here. So precedes, it occurs between two occurrence, and blah, 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 timey-wimey. But basically, it's exactly what you think, right? Like you can hold between two processes and say one comes before the other. Of course, if you assert it again, careful, if you're asserting it at the class level, saying one always comes before the other, or one always comes after the other. So let me ask you this. Descent phase. I'm going to plug in preceded by some ascending phase. Is that always true? Is it the case that a descent phase is always preceded by some ascending phase? Because that's what I've asserted here.
I don't know if there are any examples of this, but I can imagine one aircraft taking another up into the air and then the aircraft starting to actually have its own flight process only once it's up in the air.
Hmm.
So then it would have been carried up, but I don't think we would characterize that as the ascending phase of that airplane. But maybe we're not indexing
I
descent and
mean,
ascending phases to airplanes.
at this point, we're kind of quantifiers open, as they say. So like I'm open to these counterexamples. Like that seems plausible to me. You have a Matryoshka style airplane set up like fleet, and one starts spitting out aircraft babies. On the other hand, I mean, we probably want to talk about the allowing for the distribution of drones that are likely flying, from aircrafts as they're being peppered across the Ukrainian territory or Russian environment. That seems plausible. They're probably flying. They probably just have descent phase. The question, of course, is whether the initial aircraft that's carrying them to their location, is whether that's the only thing ascending in that takeoff, or whether the drones are ascending as well, as you know, or if they're just cargo being carried. I'm inclined to say the latter, but what do you think?
Yeah, although I mean, I guess I would think the same. But I guess it does say, preceded by some ascending phase. So unless we're adding on extra requirements that the descent and ascending phase have to be indexed to the same individual airplane, then I think this is fine, right?
Good observation. I love it. Strictly speaking, this is just saying some ascending phase. It could be connected to, and in fact, it's open in the model to say that the drones that are being descending later are connected to some kind of ascending phase. It was just the ascending phase of that aircraft that carried them. So if we wanted to say that, now this highlights a couple of things. One, okay, maybe we've avoided the counterexample, but also, is that what we meant? Is that what we're trying to characterize? We're characterizing like the temporal relationships between ascending and descending. Like surely there are cases like that. Do we want to allow, like in our characterization of the relationship between ascending and descending, for that kind of openness, or do we all want to be, at least characterize in some cases more specificity about exactly what's doing the carrying and what would be doing the ascending and descending?
I think considering our use case being specific would be valuable, because you might get a lot of data that like doesn't really make sense when you start looking at it. You're looking at the descent of 1,000 drones, and it doesn't add up to the math that or the way the airplane should be descending.
Mm-hmm. This is good. It's an important point to highlight. I mean, and just to kind of put a pin in that to be a little clearer, the more axioms you enforce, the more you assert, the fewer counterexamples you allow, the fewer like unintuitive consequences. And so the more you're able to infer. So the more axioms you assert, the more you're able to infer, the more implicit information becomes clear and the more precise you get about like the interpretation that the machine's going to run with. Leaving things open, you get what you get what you put in, right? Like it's sort of like this balancing act. So I think Alex's direction there is good. Like you're thinking, if we're looking at something quite specific, perhaps we should be more specific. Now there are a couple of ways to do that. It could be at the level of classes. Could also be at the level of individuals. So that's pretty specific. On that note, though, we are at time. We will pick up right here in the next session as we start building out this in more detail. I'll talk less about OWL than and more about the design pattern proper as we build our representation. So thank you all.
Thanks a
Cool.
lot, John.
Thanks,
Thanks.
John. Have a great day.
Yeah,
You guys as well.
guys.
All right, goodbye.
Big John,
Yeah, man.
that was great. I loved it.
Thanks, man. That was fun.
So let me show you something that happened a couple weeks ago when I was kind of doing it. Check this out. So I asked ChatGPT what the oldest aircraft in the Air Force was, and it answered me. So this bomber, and I got the fleet. Here's the fleet. These aircraft are from the 50s and 60s. There's 77 of them. That's their tail number right there. So the oldest one is this tail number right here. It was in Korea right at the end of World War II. It rolled off the assembly line. They just keep fixing them, right? So this is a B-52H right there. These are the engines. The internet knew that. This is the current engines. It has 8 engines on it. And then it threw in processes. Now, I did not ask this to do BFO compliant, but it did distinguish things that this aircraft has done. So, like, for example, it said it participated in this mission. It participated in this mission, red flag, enduring freedom. It had a radar upgrade in 2015, and it had a maintenance event in 2020.
Right.
Overhaul. So I started to pull these things together. Okay, these are the things it did. There's where it's stationed at Barksdale Air Force Base in California, 2nd Bomber Wing. This is that question I had about what is the history of this aircraft? So you can start to build its history. So these are all occurrent parts of the history of tail number 600001.
Right.
That's what That's what I was. And so this is all open source. This is all like Chat GPT grabbing shit off the internet.
Mhm.
There. Thought that was kind of cool.
That is cool. Yeah. Okay. I'm digging it.
So I'm thinking of writing a paper that